Every single day, trillions of dollars get moved around the globe based on financial data. But how do we actually know that data is real? I mean, really know? Well, today we are diving into the hidden world of the digital guardians that make sure the numbers we all rely on are trustworthy. Let's get right into it. Seriously, just think about it for a second. Every major business decision, every single stock price, it all rests on the assumption that the numbers are correct. But what if they aren't? This isn't just some philosophical question. Getting it wrong can be, well, catastrophic. The answer, believe it or not, lies in a set of digital safeguards we call application controls.
To really see how this all works, we're going to follow a single piece of data. We'll track it on its journey all the way through a company's system, from the moment it's created to the final report. It's actually a pretty simple but really powerful story told in 3 parts.
And here they are, the 3 stages of that journey: input, processing, and output. Now, at each one of these steps, a totally different set of controls acts like a gatekeeper, making sure our little piece of data stays pure, accurate, and totally secure. This 3-act structure, it's the absolute backbone of data integrity. So before our data can even take its first step, we really need to understand the guardians standing at the gates. These are the application controls. You can think of them as built-in rules programmed right inside the software itself, and they act as the very first line of defense to stop bad data dead in its tracks. So what are they exactly? Well, don't think of them as the building's main security system. They're more like specialized guards, each assigned to a single vital task, like, say, processing a sale. Their one and only job is to make sure every single piece of data they touch is valid, complete, and accurate, from the very beginning to the very end. Okay, let's move to our first stage and see how this all builds up. This is really where the action begins. Input controls are kind of like the super strict bouncers at the front gate of an exclusive club. They've got a checklist, and if your data doesn't meet every single requirement on that list, it is not getting in, period. And this right here, this is basically that bouncer's checklist, and it breaks down into 4 key questions. First, is the data authorized? Meaning, should this transaction even be happening? Next, is it complete? Are there any missing pieces? Then, is it accurate? Any typos? And finally, is it valid? Is this a real transaction for a real customer? If you fail any one of these, that data is stopped cold. Now let's look at a specific bouncer, the range check. It's incredibly simple, but wow, is it powerful. The system knows the acceptable range for a number. Let's say a payment has to be between $1 and $50,000. If a number shows up that's outside that range, even by a single penny, this control automatically just slams the gate shut. And here's the perfect example. Someone tries to key in a purchase order for $50,001. Because that's $1 over the preset limit, the range check instantly rejects it. And just like that, this single automated rule prevents both a potentially costly typo and maybe even a fraudulent purchase. Okay, here's another incredibly smart control. It's called closed-loop verification. With this, you're not just typing a vendor number into the dark and hoping for the best. Nope. You type it in, and the system immediately shows you the vendor's actual name. This simple little feedback loop prevents you from accidentally sending a huge payment to the wrong company just because you mistyped 1 digit. It's a fantastic defense against those common keying errors. Okay, so our valid data has made it past the front gate. Awesome. But its journey is far from over. Now it's inside the system, and a whole different set of controls, we call them processing controls, take over to make sure it gets calculated, sorted, and combined exactly right. Now that our data is on the inside, we need to make a really quick but important distinction. The processing controls we're talking about now are like the car. They do a specific job, like calculating sales tax. But that car needs a road to drive on, right? Well, that road is the IT general controls, the stable, secure environment for everything to run on. You can't have one without the other, and it's right here, in the processing stage, where they have to work together perfectly. So how do auditors even check that these automated cars are working right? They use a strategy called benchmarking. And the logic is pretty simple. An automated control isn't a person. It doesn't have good days and bad days. If it's programmed correctly, it's going to work perfectly every single time, as long as nothing has changed. So auditors test it like crazy one time to create a baseline, and then in future audits, all they have to do is prove that the control hasn't been messed with. But, and this is a big but, benchmarking isn't a free pass forever.
Auditors have to constantly look at the risks to decide if that baseline is even still valid. As you can see here, if the application is stable and the company is great at managing changes, benchmarking is fine. But if the software is constantly getting updated, or if the business itself has changed so much that the control's original logic is just obsolete, well, then it's time to go back and retest the whole thing from scratch.
All right, our data has been successfully entered and processed. It's now ready for the final act, leaving the system as a report or maybe a data file. This is the output stage, and you guessed it, it has its very own set of gatekeepers to ensure a safe and secure exit. So at this final stage, these Apple controls have two absolutely critical jobs. First, they check for accuracy. They make sure the numbers coming out actually match the numbers that went in. And second, just as important, they ensure confidentiality. They're like the final lock and key, making sure sensitive reports only get into the hands of people who are actually authorized to see them. This table shows us the tools for the job. You've got reconciliations to double-check all the math. You have distribution and encryption controls to protect the data on its way out the door. And then you have audit trails, which create a permanent record of who accessed what and when. It's basically the final seal of approval on our data's long journey. So we've seen the journey and we've met the controls that guard it. But how do we check the guards? Well, that whole process, the audit, is where we are seeing the biggest revolution of all. And it's all thanks to a new wave of what you might call robot auditors. I mean, just look at the difference here. The old way meant testing a tiny little sample, maybe 40 transactions out of millions, a couple times a year, and just hoping you'd stumble upon any errors. The new way? Automated tools analyze every single transaction 24/7. It's the difference between peeking through a keyhole and having a satellite view of the entire landscape. And this right here, this is the magic number, 100%. Continuous assurance gives you complete coverage, total visibility. Instead of guessing what's going on based on a tiny sample, you know for sure. It's a fundamental shift from reactive spot checking to proactive total oversight. It changes everything. So how is this 100% coverage even possible? Well, it's through some really clever techniques. Auditors can now embed their own little audit tools directly into a company's live system. These tools act like undercover agents, flagging suspicious activity in real time or taking snapshots of data as it moves through the system. It's how they see everything without disrupting a thing. And this all leads to a really fascinating final question. In a world where the business processes are automated and the audits checking those processes are also automated, what happens to human trust? Are we heading toward a future where trust is no longer just a feeling, but a verifiable, constantly monitored state of being? Something to think about. Thanks for joining us.